Alright, so let's go through a different example here. In this example, we're going to go a little bit quicker. Watch the last video if you need me to go a little bit slower. So in order to solve this, again, first of all, what I need to do is isolate this. So I need to subtract 1 and subtract 1, and I'm left with 2x minus 3 equals 3. At this point, this is where I split it up. Alright, I'm going to look at my two different cases. Case 1 is when whatever's on the inside is greater than or equal to 0. So go through and solve, and what we're really looking at is when I pick an x value that is greater than or equal to plus 3 divided by 2, that's 3 halves. Alright, if I pick an x value that's greater than or equal to 3 halves, then I'm looking at the positive version. Okay? The other case is when 2x minus 3 is less than 0. So whatever's on the inside, when that's less than 0, or in other words, simplifying, when x is less than 3 halves, you can go through and solve that by yourself. When x is less than 3 halves, I'm looking at the negative version of this. Alright, I can go through and solve. Just like normal, I've got 2x equals 6, x equals 3. That's one of my solutions. And that's the solution when we pick an x value that's greater than or equal to 3 halves. Let's see. My next one, I need to distribute my negative. We get negative 2x equals 0. So x equals 0. Here's my other solution, and that is the solution when I pick an x value that's less than or equal to 3 halves. So let's go ahead and make sure that we can make sense of this graphically. Here is the graph of this guy. Okay, so this is f of x equals absolute value of 2x minus 3 plus 1 equals 4. Not equals 4, sorry. That shouldn't be tacked on at the end of that. So what we want to know, what they're asking is for what x's or for what values let me rephrase that. What values are 4 away from the function? Okay, so what values are 4 away from f of x or from this function? So let's check this out. Algebraically, we just figured this out. Let's check out what it says on the graph. Again, the 3 halves is basically going to be your axis of symmetry. So if you pick anything bigger than that, you should get a particular response that's 4 away from the function. If you pick anything smaller than that, you're going to get a different response. So let's check out what responses we got. When we pick a value that's bigger than or equal to 3 halves, this is telling me that x equals 3 is going to give me something that is 4 units away. I can draw a straight line there. Something that's 4 units away from that function, and that's what it looks like on the graph. So if I pick a value that's greater than or equal to 3 halves, then the only one that's 4 units away is 3. X is 3, when x is 3. The other one is found when I pick a value that is to the left of this axis of symmetry. So if I pick anything less than x, x equal to 3 halves, then the only value that's going to give me 4 units away, like they asked about up here, 4 units away, is going to be x equals 0 when I pick x equals 0. So that's what the graph tells us. That's what the algebra tells us. The graph confirms it, and hopefully you get a better sense of what these absolute value equations are asking.